Scientists are still struggling to fully understand the perplexing behavior of the interstellar object 3I/Atlas, which continues to challenge conventional ideas about celestial phenomena in our solar system and beyond. One of the most prominent voices in this ongoing debate is Professor Avi Loeb, a theoretical physicist at Harvard University known for his willingness to explore unconventional explanations for astronomical observations. Loeb has drawn significant attention to 3I/Atlas due to its highly unusual anti-tail, a feature that has flipped in a manner inconsistent with typical cometary behavior. According to Loeb, this peculiar reversal suggests the presence of material that is fundamentally different from the microscopic dust and ice particles typically observed in comets that originate within our solar system. His assertions invite both curiosity and controversy, as they challenge the long-standing assumptions held by many comet researchers and planetary scientists. In his recent piece on Medium, Loeb emphasized that whether 3I/Atlas is a conventional icy body or an entirely different kind of object, there is no doubt that we can learn something new from studying it in detail. He stresses that the scientific community should embrace anomalies as opportunities for discovery rather than dismiss them due to preconceived notions of what is normal. For Loeb, 3I/Atlas represents a window into phenomena that cannot be fully explained by the physics of ordinary solar system comets. This perspective is consistent with his broader approach to the study of interstellar objects, which includes his earlier work on 1I/Oumuamua, the first known interstellar visitor to the solar system, and 2I/Borisov, the second. While these objects have provided invaluable insights, Loeb argues that the small sample size of just 2 prior interstellar objects makes it premature for experts to claim a comprehensive understanding of their behavior. Loeb is particularly critical of what he calls the arrogance of expertise among some comet specialists. He observes that many researchers are quick to assert authority on interstellar objects despite having extremely limited empirical data to support their claims. The assumptions built around conventional cometary physics are often applied to these anomalous interstellar visitors without sufficient justification. In the case of 3I/Atlas, Loeb identifies at least 13 distinct anomalies relative to its predecessors, 1I/Oumuamua and 2I/Borisov, suggesting that the object may not fit neatly into existing categories of comets or asteroids. High-resolution images from a Hubble Space Telescope, captured both before and after the object's perihelion passage, show that the anti-tail of 3I/Atlas has reversed its orientation relative to the object's direction of motion. This observation is particularly striking because anti-tails in conventional solar system comets can sometimes appear to flip due to perspective effects. Yet Loeb argues that in this case, the reversal is genuine and cannot be explained by the observer's viewpoint alone. The anti-tail of a comet is typically formed when dust and ice particles are pushed away from the sun by solar radiation pressure and the solar wind. In normal circumstances, this results in a tail that points away from the sun, as the small particles are swept outward along predictable paths. The unusual behavior of 3I/Atlas, however, defies these expectations. Loeb posits that the material making up the anti-tail must contain something else that is not subject to the same forces as ordinary cometary dust. This could include fragments of ice that evaporate before being influenced by radiation pressure or significantly larger debris that is relatively unaffected by solar forces. Each of these possibilities implies that 3I/Atlas is unlike anything previously observed, raising fundamental questions about the composition and origin of interstellar objects. To explore these ideas in depth, Loeb has published 3 papers proposing potential explanations for the anti-tail phenomenon. In one scenario, evaporating ice fragments could produce a temporary anti-tail that disappears before radiation pressure can reorient it. Another possibility involves larger debris pieces whose mass makes them less susceptible to solar forces, allowing them to maintain an orientation inconsistent with conventional cometary behavior. A third, more speculative, hypothesis involves technological or artificial structures, which Loeb has cautiously suggested as a potential explanation for some interstellar objects based on their motion and appearance. These papers represent a methodical effort to examine a range of plausible physical mechanisms, from the mundane to the extraordinary, while remaining grounded in observational evidence. Despite the rigor of these studies, Loeb has expressed frustration at the apparent reluctance of other researchers and institutions to engage seriously with these anomalies. He questions why comet specialists and organizations, such as NASA, often appear disinterested in investigating the unusual characteristics of 3I/Atlas. In his view, there is a striking contrast between the scientific community's willingness to explore exotic hypotheses in other fields and its cautious approach to interstellar phenomena. For example, Loeb points to recent research on sterile neutrinos, a hypothetical type of particle that does not interact with normal matter. Two major experiments, Microbueni and Cotran, were designed to test earlier reports suggesting the existence of these elusive particles. While both studies ultimately failed to confirm the presence of sterile neutrinos, they were still considered valuable scientific endeavors. The combined cost of these investigations was approximately $90 million. Demonstrating that testing unconventional ideas is recognized as an important aspect of scientific progress, even when initial hypotheses are disproven. Loeb contrasts this attitude with the reception of ideas related to interstellar anomalies. When 1I/Oumuamua was first observed in 2017, some scientists dismissed the possibility that it could be anything other than a natural object, despite its highly unusual trajectory and physical properties. Similarly, early interpretations of 3I/Atlas have been met with skepticism or outright hostility, even when observations suggest behavior that is inconsistent with established cometary physics. Chris Lintott, an astrophysicist and editor, publicly referred to broader interpretations of interstellar objects as nonsense on stilts within weeks of 3I/Atlas's discovery, illustrating the resistance within the field to entertain unconventional explanations. Loeb argues that this reluctance hinders scientific progress by discouraging inquiry into anomalies that could reveal entirely new aspects of physics, astronomy, or even potential technological phenomena originating from outside the solar system. Over the past several months, Loeb has authored 11 papers on 3I/Atlas, reflecting both the complexity of the object and his commitment to rigorous investigation. In his initial paper, he cautiously proposed that a sufficiently large solid object could have reached the inner solar system through technological design, a statement that was removed during peer review at the insistence of his editor, Chris Lintott. Undeterred, Loeb later co-authored a full paper exploring the potential technological origins of interstellar objects, presenting the idea as a scientifically grounded hypothesis rather than sensational speculation. This work exemplifies his broader philosophy that anomalies deserve thorough and open-minded investigation, even when they challenge prevailing scientific dogmas. Loeb emphasizes that the study of interstellar objects like 3I/Atlas is not merely an academic exercise, but could have profound implications for our understanding of the universe. If these objects are purely natural, their unusual properties may still reveal new aspects of astrophysical processes, comet formation, and the behavior of materials in extreme conditions. If they are artificial, their existence would provide evidence of extraterrestrial technological activity, fundamentally altering our perspective on life and intelligence beyond Earth. Either outcome underscores the importance of maintaining scientific curiosity, rigor, and openness when examining anomalies that do not fit neatly into established frameworks. The controversy surrounding 3I/Atlas highlights broader issues in the scientific community, including the tension between conventional expertise and the need to remain open to novel ideas. While specialization and deep knowledge are crucial for progress, they can also create blind spots when experts assume that existing models are complete. Loeb's critique of the arrogance of expertise serves as a reminder that scientific advancement often requires challenging assumptions and exploring unexpected phenomena with intellectual humility. Historical examples abound, from the discovery of Neptune, whose existence was predicted based on anomalies in Uranus's orbit, to the detection of pulsars, whose unusual signals were initially dismissed as experimental noise. In each case, the willingness to investigate anomalies led to breakthroughs that transformed our understanding of the cosmos.